Okay, we're continuing 5.6 with L'Hopital's rule. And just a reminder that in order to apply L'Hopital's rule, we need to have both the numerator and denominator need to be differentiable. Yeah. I guess it should be clear that it needs to be differentiable at that point, because this function is not differentiable everywhere. It's only differentiable for values for x that are greater than -2, and 2 is definitely greater than -2. And then the other piece is, I don't care if you write arrows as if you plugged in 2 in for the numerators, but you definitely should not be writing equals 2. So if you were to write equals 0 divided by 0, you will not earn that point. I think you'd be fine if you just put like a giant arrow like this. I got in the habit though of putting an arrow from each piece to say that. So my preference would be to see individual arrows. And if you want to, you can even show like the square root of 4, because 2 plus 2 is 4. They expect you to be able to do most of this math in your head. 2 minus 2 equals 0. So some sort of statement that explains why 0 over 0 implies L'Hopital's rule. So then you can take the derivative of the top. It would be 1/2. That x plus 2 is now to the -1/2 power all over 1, the derivative of the bottom. And now when you plug in your direct substitution, now you can, where you have 1 over 2 square root, the negative power puts in the denominator. The 1/2 is the square root of 2 plus 2 is 4. And square root of 4 is 2, so we're looking at 2 times 2, which is 4. A lot easier. Well, I shouldn't say it's a lot easier, but certainly easier than some of the things that we did before. So if we plugged in 0 into this problem, yes, this function is differentiable to the left and to the right of x equals 0. So you don't have to write this down, but I want to be a good teacher where I'm saying, hey, it's differentiable in the top, differentiable in the bottom. And when you plug into the numerator, so we have the square root of 1 minus 1 minus 0. Okay, that does equal 0. And in the bottom, you can even make that note of 0 squared is equal to 0 as well. So 0 over 0 implies L'Hopital. And then you can take the derivative of the top, limit as x approaches 0, bring the 1/2 in front. X plus 1 is now to the -1/2 power. Derivative of -1 is 0. Derivative of -x over 2 is just 1/2 all over 2x. As you look at that, well, 0 plus 1 is still 1. To any power is still 1. We have 1/2 minus 1/2. We get 0 on top, and 2 times 0 is 0 on bottom. So we L'Hopital again. So bring that -1/2 in front. X plus 1 is now to the -3/2 power. The derivative of -1/2 is 0. Derivative of 2x is 2. And same thing as before, but now we can put equals because 0 plus 1 is 1. To any power is still 1. We have -1/4 divided by 2 will give me -1/8. And it's at this moment that I realized that I was working on the homework. So I'm going to save this video and embed it somewhere in your homework slide. So if you get stuck on 7 or 8, here you go.